Alright, so this next video is going to look at using speed, distance and time calculations. A couple of things to remember before we start this is if you get stuck with recollecting the formulas, you've got your little triangle to remind you with distance on the top, speed here and time here. That triangle obviously telling you if you were asked to find distance, you would do speed times time. If you were asked to find speed, you would do distance divided by time. A couple of different ways to remember why the triangle fits together. It's all to do with D being at the top. You can memorise that D is the first letter in the alphabet, so that's the first one we write down. Or again, we've got the kind of image that I've mentioned a couple of times of how I was taught this, of remembering the triangular D for dunce cap that children were made to wear in the dark ages when I was at school. What else we have to think about is that it might not be simple enough that you'll be given the time. You might be told something like someone departs at let's say 8:45 and they arrive at 10:15, and you need to work out the time in between those things. And again, we could do that using working, such as I have 8:45 and I'm going to then jump up from 8:45 to 9 o'clock, 0900. I know that that's 15 minutes. I'm going to then jump from 9 o'clock to 10 o'clock. I know that that is 1 hour. And then from 10 to 10:15 is another 15 minutes. And I know then that's 1 hour, 15 minutes, 50 minutes, that's 1.5 hours. Let's look at an example of a question or two though. So, a bus leaves Dalry and it travels for 5 hours at an average speed of 46 miles per hour. How far will the bus travel? So let's look at our three variables. We have distance. Looking at this question, I don't actually know what distance is. It's asking me what distance is. I have a speed of 46 miles per hour and I have a time of 5 hours. Excuse me. 46 miles per hour and 5 hours match up, so I don't need to change anything here. I can just plug these into my formula. Distance is equal to speed times time, which is speed of 46 multiplied by a time of 5. 46 times 5 we could do by writing out a calculation, or again we could lean on this might be a calculator question. So 46 times 5 will give us 230 miles. Okay, one more. Kai travels 40 miles from Gretna to Dalbeattie. He covers that journey in just half an hour. Did he stick to the 60 miles per hour speed limit? So I look at a question like this and I see that I have a distance of 40 miles, I have a time of half an hour, and I have a speed of 60 miles per hour mentioned in the question. So all three variables are there. What is this actually asking me to do? What is my reading the question telling me? It's asking me, did he stick to the 60 mile per hour speed limit? So it tells me that the speed is not certain and I have to find out what the speed was, and I have to give some kind of little statement about whether he stuck to 60 miles per hour. This bit here though, half an hour, I have to think about putting that into my calculator properly. That's 30 minutes, but I'm not going to do 40 times 30 because that's going to tell me that Kai is travelling at 1200 miles per hour. He's, breaking the speed of sound and things like that. So my distance is 40. My speed is what I don't know, and my time is a half. Okay, so I'm going to look at my formula, and I'm going to do that speed is equal to distance divided by time. And I realise now that I was, when I gave that 1200, I was using the distance formula. So ignore everything I said in that comment. So speed is distance divided by time, which is 40 divided by a half divided by 0.5. And what does 40 divided by 0.5 equal? Forty divided by 0.5 equals 80 miles per hour. So the question is, did he stick to the 60 mile per hour speed limit? No. I have to show that I've compared two numbers. He went 20 miles per hour too fast. Or I could just say that 80 is bigger than 60, so no. Did he go too fast? Yes, he did. He was speeding.